Okay, well, let's get going. Welcome, everyone. Good morning in Southern Africa. A little bit later in the night in New Zealand and Australia, and we might even have people from North America again. But thanks for joining us. This is the second in a series of half a dozen, and it might actually extend to another one after that, on gold. It's pulling some of the keynote talks out of Gold 24 from late last year, the conference, and putting it together, a little bit of a parcel aimed at particularly Southern Africa, touching on the Wits, touching on other things, and ideally targeted so postgrads and students can join us as well. They're very welcome. Obviously, quite a few people can't join us, but three in particular have said apologies, please. One is Dave Craw, who spoke last week. He will join us again after tonight. Bjorn von der Heijden is fieldwork today, and Alex is fieldwork. Alex Kisters is fieldwork too. So these guys are all just unable to join us. We had a lot of interest last week following Dave Craw's talk. It's been people coming back and saying to John Bristow how wonderful that was. Lots of comments by email too, and also quite a lot of debate. And I think Spike McCarthy has contributed and said, hey, he thinks he's got some things to add on the New Zealand part, but particularly his knowledge on the Witwatersrand, some great stuff and slides he's got. So we want to hear that. But the general feeling is it's sort of a talk rather than a quick 1 minute mention. So we'll try, and we're talking about putting that after Keith Kenyon in April. A little bit on Julian Vearncombe, who is English originally, spent quite a lot of time and is still living in Perth, Western Australia. After his PhD, he went to South Africa, did a postdoctoral fellowship at University of Wits in what was Rand Afrikaans University at the time, or UJ. And a lot of that was focused on the Murchison Greenstone Belt. But in that time, he obviously picked up a lot about the wonderful Southern African geology. He then went to Perth, where he led the industry master's course at University of Western Australia. Incredibly successful venture, and he can correct me, but I think at one stage they probably had 50 or 60 part-time master's people, so a huge job making that work. Since then, he's had roles in industry, very strong on the commercial side as well, and research, and he's managed to keep those three all going, which is a great combination. He's played a big editorial role in applied earth sciences, the special issue coming out. Well, he was the main organiser of Gold 24 and several other conferences in Perth over the last 10 years, and does a huge job editing those volumes. I think the other thing, he plays a big role in the Perth geological community there, bringing people together and also making sure that universities and students sort of stay online and don't just exist in a bubble, but get out and talk to people in industry and where the edges of science are moving.
So what I'm going to talk about tonight is something that is obviously based on a large amount of experience and years, but it arose from fieldwork that we were doing in the South Island of New Zealand, and discussions that came out of that. And I will explain that in more detail just shortly. This is part of a submission, which includes co-authors Neil Phillips, Andy Barnicoat, June Cowan, and Dave Craw, who spoke last week. However, some of the material here is different, and to talk in the manner of the research paper would mean that you're all going to be, those of you in South Africa are going to be here at midnight, and I would have to be here having my breakfast. So I've shortened it, and I am presenting this in a different manner with different content. So I think that over the years, there are two views that have developed on the Witwatersrand. And the one that's dominant, probably in South Africa and Germany, is that the Witwatersrand Basin is different from most Archean. It hasn't enjoyed intrusive granites, and it's got a stratigraphy you can trace for hundreds of kilometers. Because you can trace it for hundreds of kilometers, there's therefore little deformation. There are 7 major goldfields, and we can interpret each of those, and in those goldfields, more or less similar positions are mineralized. And we can easily interpret those as sediment input points. And then when we go underground, we find gold in conglomerate of a couple of other rocks, but mostly a conglomerate. That conglomerate, when we look at just the conglomerate, doesn't look that deformed. Therefore, we can interpret it as a syngenetic placer, just like the placers in New Zealand. And because it's also simple, we can largely ignore structural geology and the literature on deformation. And that is a view. I certainly heard that view expressed in questions and comments last week from Dave Craw. The other view is that it's hydrothermal, or what I prefer to call it, which is rheology type mineralization. The point is that the metal is there because of not the strength of the rock, but the relative strength of the rock to the adjacent material. And what I want to show in this talk, and this is all based on existing literature. There's no new work here. There's nothing I am going to say that has not been said before and is not published or at least widely available. And the first point is that the Witwatersrand is actually quite highly deformed, and it's deformed in all goldfields and at all scales, from the scanning electron microscope, sub-millimeter, to the scale of the basin. And that's been said by many. And also that grade is structurally controlled, that the grade follows structures. And that has been said by many, but what has not been said is that conjunctive, that it's deformed at all scales, and that's the important word, grade is controlled by structure. And when you adopt those two, you have to accept that it is rheology type mineralization. So on the left, a photograph from Neil Phillips. Here we are, we can go underground and we can have a look at this conglomerate, a nice reef, and we can have a look at this conglomerate and say, it's undeformed, therefore it's a placer. And we just ignore the brilliant piece of structural geology and all those quartz finds and the layer parallel slip in the quartz vein fault combination immediately beneath the reef. So what I'm going to do is a big picture talk. I'm going to go over the Witwatersrand is deformed. Then I'm going to do structures control grade. Then we're going to have a look at the tectonic setting, specifically at 2650. And then I'm going to talk about the economic future of South Africa. So the first paper we published from our New Zealand work was this one, which is about unconformities in New Zealand and the comparison of where the gold is with the Witwatersrand. And without going over what Dave talked about last week, let's just make the point now unequivocally, the gold in New Zealand is in different positions in these placers to the positions of gold in the Witwatersrand. It's at the base of the unconformities in New Zealand. It's in the talweg of the channels, and it's on the beaches. There is no planar sheet gold in New Zealand. the things that matter on the Witwatersrand are that gold is actually in diverse host rocks. So gold, and I'm talking here anything above, say, 1 gram per ton, is in a whole variety of rocks. Yes, the super high grade is in the carbon-rich rocks and the conglomerates, but it's in a whole range of rocks. Secondly, the gold is occurring over host rock ages from the Dominion to the Black Reef. That is about 400 million years, or at least it was until somebody showed us some new dating on the Dominion, where you could maybe knock that down to 320 million years. But that is longer than the geological history of where I'm sat at the moment, which has a basement of Triassic. And if we talk in European terms, that period, even at 320 million years, is 2 orogenic cycles. It's therefore bonkers to have some sort of special placer, special origin of gold process that operated through this massive change in geology. In that 400 million years, the Witwatersrand went through rifting, thermal subsidence, fallen basins, graben flood basalts, and late outer basin compression. You can't have some special plating event that applied to all of those. So this is not the Witwatersrand, this is St. Bathams. These are Miocene to Holocene channels. And the gold, despite the fact that much of this material has been mined, mostly by, I did not intend to do that, let's go backwards, by sluicing, most of the gold was just at the base of this particular channel. And the channel has got a history of multiply repeated placer processes for 20, 10, 5, and way up into the Holocene. The Witwatersrand does not look like this. So big picture introduction, we got there at last. So I think you guys know, I spoke in Dunedin, I had to explain where Africa was, but I think you guys know. The one thing that I note, and I have no proper explanation, but there should be a PhD working on it, is that you've got 3 to 4 Precambrian basins which are sitting on top of each other. Even in Western Australia, where we've got similar basins, they don't actually sit on top of each other. They're not successors in this particular way. And that's something that we need to find out and learn more about. Now, the structural geology of the Witwatersrand is a story of people doing really, really good work and the results not being followed through. So Brock and Pretorius wrote about structural aspects in the past have not warranted attention, a nuisance value. But then people like Chris Röhring, and Chris used to take people like myself, Andre Smith, Steve McCourt, out to look at things. We'd all agree, we'd all notice the cleavages, the faults, the repetition of strata. We could agree on a cross-section like this one through Svartkops. And then at the end of the day, Chris would say to us, and this shows that the Witwatersrand's deformed, and I never understood what Chris was saying, because if he'd been awake earlier in the day, why was he saying this? And the reason he was saying it was the sheer frustration at getting the message across. And again, Röhring and Smith wrote a complaint that north displacement thrusting was well documented, but not readily accepted. So there's heaps of good work, but the second publication, the third publication, has not been developed. Now, this is a graph on the y-axis up here of millions of ounces of hydrothermal gold. And this on this axis is age. Today we're here, and I guess one of these circles relates to New Zealand. We go older to the left, and here we see the Murchison, and here we see Barberton. It is absolutely bonkers that anybody could ever suggest that these here could be a detrital source for that. Even if we had the Yilgarn and the Abitibi able to feed the Witwatersrand, there ain't enough gold. And it is bonkers again to suggest that this could have a source which we can't find any evidence of. And obviously it's a bubble plot to prove the amount of time that I've spent in industry rather than academia. Now, I possibly don't need to go over this, and there's far too much in this, but these here in the stratigraphic column, from the Dominion to the Black Reef, represent that 400 million years, or maybe we have to change it to 320 million years now, with gold reefs here, 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 and here. And whilst you may argue, look, oh, the really good ones are here, there are, throughout the sequence, gold reefs, and nobody would object to finding these sorts of deposits in somewhere like Western Australia or New Zealand. There is gold in the Black Reef and those blue dots here. There is gold in the Dominion in the green squares, I think. And above all, a history of subsidence, extension subsidence, then compressional, fall and basin type things, extension subsidence. I also flag, because I really don't want to get over involved with this Black Reef thing, but the Black Reef, although it's assigned by a committee to the Transvaal, it is a mega gap between it and the rest of the Transvaal. And if I had a PhD student working on the Black Reef today, I would be making them walk it out and showing that the mineralized Black Reef is the same as the Black Reef that sits at the base of the Transvaal, round in, say, the Murchison, for instance. I've only put this in really in case I need it later when you ask me a question about a goldfield and I can't remember where on Earth on the planet it is. So I'm going to move on quickly from that to the Witwatersrand is deformed. And one of the critical pieces of information, so this is from Henk de la Rey Winter, and it shows the multiple unconformities that are the classic arrangement for a foreland basin. So we are uplifting in the west, we're consistently uplifting, and we get unconformity after unconformity after unconformity. And then we get the major unconformity at the Ventersdorp contact reef, which is something like the Waipunama erosion surface here in New Zealand. So that's syn sedimentary deformation. That then goes through into the deformations that Henk reports from, well, the northwest, essentially, of the Witwatersrand, where we see that those structures that were uplifting also then propagate into the goldfields. Locally, we've got overturned strata, and we've got thrusting, be it small-scale thrusting in this section and much more dramatic thrusting in this section. And then we go through into a later deformation, which is mostly out of the basin. So this top one, a scale there is just a meter. This is underground. This is gold reef material from Paige Pitts's master's thesis, showing these thrusting to the north underground on the East Rand. This one is also from Paige Pitts's thesis, but it's a complex pillar. So this is south, this is north, and this is north, and it's about the same scale. and she's mapped around the pillar, and we see these dramatic duplex type thrust structures in the ore zone underground. This is from Chris Ruering and Andre Smit on a road cut which 30, 40 years ago was less than salubrious, and I'm guessing is maybe not even that safe these days to go there. But they measured strain and reported on these major thrust movement here in a suburb of Johannesburg. And finally, this is the section of Chris's through Svartkaps, and we see Witwatersrand on top of greenstone, on top of granite, on top of Witwatersrand, on top of greenstone granite, and a repeated alpine type duplex thrusting. Curiously, that deformation, really, really obvious. You don't need much of a travel graph from Johannesburg, but that deformation is ignored in a number of reviews on the Witwatersrand. This is Jolly's work underground Carltonville, and here in white we see the Ventersdorp contact reef, and we see the mapping in fine detail of all the structure in this gold horizon. So ultracataclasites, faults, fracturing, philonites, myelinite along this particular horizon that is more than economic. And thrust fault rocks are common. These are from Andy Barnicoat, and they're detailed of a fault rock a bit shaly and a much more combatant rock here with Port's Pyroclasts, where you can see the movement sense. The point that I'm making is that there is lots and lots of evidence for deformations, but they've not been put together. This is Elandsrand, and here we've got conglomerate reef and a thrust fault putting the conglomerate reef up higher in this position here. Again, these are the sorts of things that need to be documented in detail underground on a daily basis. These are the sorts of things that we need MSc and PhD theses talking about in detail. This is taken, and I need to thank Greg Hall for this. This is when Placer Dome held Western Areas, and it's from the Millstream pit. So this is black reef material showing not just the unconformity, but thrust structures. So this is an interpretation, a hand drawing of this here from that pit. The point is that thrusting is not just occasional, it is common, but it is completely it's documented in places, but it's not put together. In some ways, this is a brilliant diagram. In other ways, I don't actually like it. It's again from Placer Dome and Greg Hall, and it shows the situation with the earlier thrusts from the west, the unconformities, and then the out of basin thrusting, and how we get the mineralization along the VCR and in units beneath, but dying with depth. The reason I'm not totally keen on it is because I don't like structures that just appear by magic. Structures have to root, and that rooting and driver of these structures is not recorded in this diagram. Nevertheless, it shows how we get the different deformations, the unconformities, the strong compression and thrusting from the west, and then the out of basin thrusting, which is almost certainly the gold mineralizing event. Now, structures control grade. So lots of people will say, yes, the structural geology in the Witwatersrand, but that's not the control on grade. I want to show you here that there is substantial literature showing that structure controls grade. So here we start off with the Leeds work, and 40,000 gold grains were examined by the Leeds group, and 40,000, that's 100% of them, were in secondary positions that were not in the rock at diagenesis. So they occur in fractures like this and like this. And the fills and the temperatures at the time of these fractures in the material, they estimated at 250 and about 2.5 kilobars. Again, more of these micrographs. Most of them are well, no, they are from different places in the Witwatersrand. I think the previous one, no, I apologize. I think the next one says where they come from. Again, a fracture, metamorphic minerals in that fracture, and gold. There's gold somewhere. There's gold here and here. Again, a fracture. Another fracture zone with gold and pyrrhotite. And gold again in a fracture running through here. No primary source gold found. Therefore, it has to have come in at the time of metamorphism, at the metamorphic grades of the minerals that are sitting there with them. And this one makes the point that this is Western Deep levels. These are Elandsrand and Deelkrall because they looked at a number of mines, but again, fractures through here, that's got galena along it, and this has got gold along it. And then there's the famous sample where some very strong words were used, and one group took the gold out by dissolving away the silicate, and the other group looked through an electron microscope, and they came to completely different answers. The electron microscope work is here, and this shows all the gold on fractures. The gold in this sample is tectonically emplaced into the rock. It was not there at sedimentation or diagenesis. Moving up scale, this is from the Vearncombe field, and this is a Connolly diagram produced by Greenberg. And we see here the antiforms, the synform. I could possibly have, I put the red on the original plot. I could have also probably put a bit of a high for antiform here and here. The synform in blue, the antiform in red, a synform in blue, an antiform and an antiform over here. And what we see is that the gold sits on the antiforms, and this tight synform in here has no gold on it. And again, the workings are on the antiform and not on the synform. They're along the antiform and not the synform. And again, they are along the antiform. So at the scale of a mine, at the scale of you doing your work, the antiforms host gold, the synforms don't, just like Ballarat Bendigo. If you weren't persuaded by that one, this one is much, much clearer, which is in the East Rand, where in red, we have a major antiform running up here. And these folds are discontinuous. They're non-cylindrical or whale-back structures. Here's a syncline without the workings. Here's a syncline without workings. And here's an anticline with workings and an anticline with workings. And another syncline coming in here without the working. The folds, the anticlines host, the synclines do not. Again, with Greenberg's work, Eastrand, where we see syncline without gold, anticlines with gold. And here we see a lot of gold associated with the anticline, but only on one side. And I would speculate that, in fact, so that's the cross section. There is also a fault along this line somewhere here, and that's why the grade is stopping so quickly. June, who's been working with us, took two of the pieces of work, essentially the Minter 76 and Fremel 2005, superimposed the information. And this was used in the past to say that these black lines, which are supposed to be some sort of channels and flow directions, I don't understand in a braid seam how they can all be so straight. And I would ask, I mean, any sedimentologist who wants to argue with my content towards the end of this talk has to tell us what the basis of those arrows is. Is it crossbeds? Is it channels they mapped, etc.? What June sees are these faults, which are on one of the maps, and these cross faults, which correlate far, far better with changes in grade. And these are Perkins discontinuities. These are the breaks in the rock which existed before mineralization, which act as barriers to the transfer of fluid through that rheological unit, which is hosting the ore body. So in a moment, I'm going to show you a movie of that, but this is the gold isocon. And remember, the channels are meant to be going that way, but what we see is that the high grade gold goes down the antiform here and is missing in the synforms. So here we've taken the data that was used to say it's sedimentary and shown that in fact it's almost certainly structural. Now this is the point where this all blows up on me, because I have to try and show you a movie. So in purple are the faults that are important, and in black are the not so important faults for all this. And in a bit, we're going to have grade and things like that appearing. This is what happened to me yesterday when I tried it. Try again. I don't seem to be able to click it to stop the movie without moving a slide. So I'm going to just run the movie through. And what you need to do is to see the gold going down the antiform. And the detail in the gold matches cross faults far, far better than it ever matches channels. And just this morning, I was sent a PowerPoint. So thank you, Spike. Look at all these Perkins discontinuities through here, through here, through here. All these cross structures. These are the things that need to be researched. These are the things that we need documentation on. Yes, some of them will almost certainly be due to a tenement boundary. Some could be post-mineralization faulting, and some could be corporate decisions. But there are just too many of these structures like that, look at all these through here. These are almost certainly Perkins discontinuities, and they show mineralization along the rheological unit, the strong unit which only fractures, and that mineralization stopping and changing grade on the barriers, which are the faults. So let's move on. So if we have persuaded ourselves that it's structurally controlled, how does it sit? Well, the Witwatersrand is here, and we have the really early pre-Witwatersrand thrusting from Eswatini up to the north, for instance. Then we have the Basin age structures, which are the accumulation of island arcs to the north, and the thrusting from west to east in the Witwatersrand and the Foreland Basin. And then we have the out of basin thrusting, the event that is most likely to be the control on mineralization, which occurs at the same time as the Limpopo indenter coming in here. And if those are mechanically related, clearly the Witwatersrand gold deformation is a back thrust relative to the Witwatersrand. I've put this together and we can go through it pretty quickly. At greater than 3 granite greenstones, accumulation of island arcs to the north, docking of the island arcs to the north, Limpopo collision, granulite fascies metamorphism, and then regional extension in the Transvaal, and much later folding along the Mashlepitsi. In the Witwatersrand, rifting, post-rifting thermal subsidence, Foreland Basin, grossly asymmetric, coarsening upwards and migrating to the southeast. Sea level erosion, a sort of Waipunama erosion surface here, and then the West Strand Basin, bimodal volcanics, and those sorts of things associated with the Ventersdorp. In terms of stratigraphy, Dominion, Lower Wits, Upper Wits, Ventersdorp, and then Kunisport and Pretoria group, obviously up here. And in terms of gold mineralization, Barberton, unrelated, Murchison, unrelated. There is the granulite grade metamorphism, but the gold is not dated in the Limpopo. It's only the metamorphism of the gold that's dated. And I would suggest that this is the timing of Witwatersrand gold mineralization. And again, unrelated to Pilgrim's Rest and obviously the minor gold in the Bushveld. So the overall story, this is from Beach and Smith, extension, particularly related to the Dominion, and then an advancing gold front here. So the advancing front here, and then late we see thrusting out on this side, and then the reversal. But this highlights some of the massive problems we've got with structural geology. This was published by 2 people, pretty well known to all of us. Section C is here, so that's this section. Section D is here. These 2 sections are so incredibly different that should ring alarm bells amongst most of us. And I would suspect that there is a major lateral ramp in this position here. It certainly needs to be researched. You can't have adjacent cross sections which are just so incredibly different. So the overall story is of thrusting from the west, in this direction, followed by some extension. The west thrusting makes it through all the way across the basin, and then an out of basin thrusting, some of which is Ventersdorp, post-Ventersdorp, sort of pre-Transvaal. And this is a combination of the work of people like Mike Coward, Alistair Beach, and Rorik Smith. So the sort of model we would come up with is something like this. And it was pointed out to me 2 days ago, this looks just like Macrae's in New Zealand. Some sort of thrusting involved, but the movement of fluids, not just along these thrusts, these metamorphic fluids can move along the strata by microfracturing, all those microfractures that we saw in the SEM data. And we can have specific horizons through here which enjoy more microfracturing than the other because they are rheologically so different to the surrounding rocks. And we've hedged our bets a bit here, whether the gold really comes from outside the system or whether the gold is actually all inside the system. And obviously some of it makes it to the top of the Ventersdorp supergroup. So how do we have a new economic future? Now, I think the truth of the matter is that most people don't have $100 million in their back pocket to go off and pick up ground and start to do things. But how could a mine geologist, how could an exploration geologist start to change things? Well, this was a really important distinction that came when Placidome held Western Areas. And they stopped the practice of just assaying the bit that you knew was mineralized and was going to be good, and assayed the whole section all the way through. So this is a linear graph, and this is a log graph of the same data. But what you see is that whilst you may have mined that, and that, the shoulder to this is absolutely fantastic. There's 72 meters of shoulder, and here it's even better in this drill hole. The shoulder to mineralization is the economic future here. And if you took this to the mining department, if it was at Macraes here in New Zealand, or if it was in Kalgoorlie in Western Australia, nobody would be thinking of mining that. Everybody would be thinking of mining from there down to there, from here all the way up to here, and taking it all out. Now, I know that the South Africans are all going at 3 meters, 3 kilometers or 4 kilometers depth. And yes, that's going to be a massive change in mining. But think of all those things near the surface where that's been mined and all this is still there to be worked. So let's have some key points. Abundant evidence for structure. And I've not really talked about fluid, but all those structures have fluids coming along them, particularly the microfractures that we saw. There are major faults and there are small faults and rheological contrasts which result in a microfracturing of the strong rock, particularly those at the unconformity boundaries. There are widespread occurrences of anomalous gold through all sorts of rocks in the Witwatersrand over 400 million years, 2 orogenic cycles of host rock, 2 orogenic cycles of host. Gold grades follow structures, and the only circumstance where they don't follow structures is when the structural geology is not being done. It's late Archean thrusting out of the basin that is probably related to the controls on gold. And it occurs at the same time as the globally consistent Archean hydrothermal event at 2650. And that is also in Southern Africa, where we see the Limpopo, which is the first documented clear Himalayan type of collision. So what are my recommendations? How do I totally upset all the audience? We need much, much more knowledge of the 3D structure of the goldfields. Our mine geologists need to be trained up and leaving the mines and doing PhDs on the mines they used to work on, documenting all of this. What is the future of exploration? The future of exploration, as the gold price soars, somebody can type in the notes here what today's gold price is in rand. In New Zealand dollars, it's over 5,000. In Australian dollars, it's over 4,000. In US dollars, it's over 3,000 an ounce. So what happens as the gold price goes up is we can mine more and more peripheral material. We need to stop any contouring, any smoothing of grade data. Only deal with point color-coded grade data. Do not smooth, do not contour, do not Krig those data. And then when you look at the data like that, you will see the Perkins discontinuities that you wouldn't have seen if you smooth things. And just because I want to be really confidential, my final point is that confidentiality is weakness, and you guys are not allowed to use the word confidential in any question that you ask me now. Cheers. Over to you guys.
Thanks, Julian. That was tremendous and lots of food for thought. So I'll hand back to Neil. Neil, you're going to run the question and answer session.
Yes, I think I'm back on now, John.
Yeah, you're there.
Was probably nothing controversial there, so we may not have any questions. I don't know. Let me open it up and say, happy to take questions. You can use your little hand, or you can just speak up.
Just looks a little bit different.
Keith Kenyon to start.
Good morning, Neil. Good morning, Julian. Julian, excellent talk. And it's going to lead in quite a lot to what I'm going to say in the future. One question, and this relies on your structural knowledge, which I don't have. Is it possible that structural relationship with the mineralization, actual mineralization, post-dates those structures by quite a long way, despite the fact they control them?
I don't
have a reason for asking that. We have some
initial. The gold gets in with chlorite, pyrrhotite, those sorts of minerals along the fractures, and the gold can't just come after the structures.
My problem is that I have going to show some of the work that I did with Andy, which we never followed, Andy Barnicoat, which we never followed up on, and I'm going to, and the reason I'm introducing it now is that I'd like people to think about it. The gold in the carbon seams, it shows a strange planar phenomena that has no fracture there. It looks like something has come through at very high speed. And I'll show you microscopic evidence of this. And this is why I'm asking the question. Is it possible that those structures control some event that the gold is distributed along them at a later time? We've got some ages on. We've got some ages on zircons which are not real.
The carbon seams are going to look different because obviously the carbon is I mean, if you remember at the beginning, I said it wasn't rheology, it was rheology contrast. And the conglomerates are really strong, whereas the carbon seam is really, really weak. And most of the gold is in the same position as petroleum would be in a petroleum basin.
There's no argument about that. And I mean, I was involved in all the work that determined the source of that carbon. But there's some things which I've been staring at lately which are confusing me. And this is what my talk will be about later. And the reason I'm introducing it now is that I'd like these things to be thought about. For instance, I'll show you examples of orthogenic zircons, which are giving dates which we can't. In fact, there's no possible date for them because they've got so much uranium in them that there are no standards. I did this, and I'm going back to Richard Armstrong in a couple of days' time to try and get him to find those things. But what I'm going to introduce is a lot of the old work that we did back in the 90s that has never been looked at. And again, like you, this work is going to have to be followed up as future research. And therefore, I'm just putting it out there now that I have a concern that the gold itself actually post-dates the actual structures by a while. And I'm trying to understand why I get this, or looking under the microscope, and I look at it with some of the evidence that I've collected. And
Uh,
I may be completely
I
wrong.
think I can answer some of that, Keith, partly because somehow your data made it to Placidome, and Placidome became leaky, and half the world has, if we're honest, seen the data already. That 2330 age is very broad. There's a lot of
It is.
scattering
It's very, very broad.
data. And 2330 is the gap. I mean, it is one of the least exciting periods in South African geological history.
Absolutely.
It's the gap between the Koenigsport and the Pretoria group. And we pinned the data that we had through our local geochronologist, Neil McNaughton. And Neil said, you know, look, they're orthogenic, they've been dated, but do you really believe the detail?
Well, let's address that. I think that's a good point. And let's address that because, yes, do we really believe the detail? The problem is from my side, which is spending a lifetime looking down a microscope, is I see a lot of the detail and a lot of it is actually quite confusing.
Okay, well, the solution to that is to give up isotopes, give up geochemistry, give up sedimentology, and do the structure.
I thought you'd say that.
Okay, Keith, look, thank you for that contribution. Let's take that as a topic on notice. I mean, Keith's going to talk about it in 3 or 4 weeks' time, and it's probably a good one to think about and follow up. Anybody else got questions?
Yeah, Neil, I can spike here. I can make a comment or two.
Absolutely.
You know, one of the things you've been talking at length about structure and thrusting and stuff like that. But one of the issues about this whole structure and its effect on gold and whatnot is the chronology. You know, if we look at something like the East Rand Basin, prior to the deposition of the main reef, the Nigel Reef, as we call it there, the main reef, there was quite a bit of folding. And the deposition of the main reef, you know, these big flat placer type things. And then subsequent to that, there was further deformation. But the most intense deformation actually relates to the post-Transvaal deformation, which is Vredefort. So you're looking at a period there of a couple of 100 million years in which there are multiple deformation events. And each one obviously had its effect on the gold. But the one significant thing is that the gold stayed in place on a lithological scale, but on a microscopic scale, the gold is going to change with every little push of every little adjustment in the metamorphic grade, the local metamorphic grade. So this concentration on microstructures is not going to be helpful.
Spike, I have to stop you there. This small scale migration we see when we get a carbonate grain and it's stressed a little bit, and we see the carbonate that moves to the pressure shadow. We see the same with a quartz grain where the high stress points lose the material and the quartz migrates to the pressure shadow and maybe the neighboring quartz vein and that sort of thing.
Yeah.
The problem with the Witwatersrand, and you can say the gold has migrated and we see where it migrates to, but nobody has shown us an example of the gold before it got moved anywhere.
You won't find it because it's all been overprinted multiple times. Everywhere. You'll never find what you're looking for.
I can find pebbles. I mean,
Pebbles, sure.
Right, the Witwatersrand's a placer. It's a quartz placer. I can find quartz pebbles.
Yes.
There are very little deformed at the stope scale. At the micro scale, they're deformed because they've got fractures.
The point being?
The point being that all the gold, if you give up the idea that it's a placer, just forget about it being a placer, the gold is in fractures.
The gold is in conglomerates.
You're only talking
gold
because
is
you
in
want
conglomerates, not fractures. The gold is in conglomerate bands, which were deposited sedimentologically, and it never moved out of those bands.
Well, that's
Come on, Julian.
That's contrary
your
to
scales right, man.
40,000 gold grains looked at by the Leeds Group.
Because they're looking at the same thing over and over again. Did they look at what's happened with the quartzites? There's no gold in the quartzites. There's no gold in the shales. It's all in the conglomerates. Why? Because it's a sedimentological deposit.
Our chairman's published that there's gold in those other units.
Our chairman,
Watch
our
it.
chairman and I don't agree on a lot of things. But the one thing I think is clear about the Wits, the gold is primarily associated with conglomerates, in coarse grade conglomerates. That's it. That's a fact. When you look at it under the...
Yeah,
probably would have said the number one
that's a
association.
great geological.
Sorry, we're losing track here. What's going on?
I was going to say
I would agree. A lot of it is in conglomerates because it's rheology controlled, rheology type mineralization.
Oh, okay. Well, we'll never agree on that one. But the other thing is that a lot of the structure, you know, you've got all these thrusts going up in and out of the basin and whatnot. And when you talk about the Carltonville goldfield, which is where a lot of the work has been done, the major thrusts, they are actually related to the Vredefort Dome, which you didn't mention at all. It is a major basin-wide deformation of incredible magnitude, and you don't mention it. Julian.
It was actually on a couple of diagrams, but I didn't want to over-confuse, yes.
It is the primary deformation in the Carltonville goldfield. The VCR is an absolute mess structurally because of the thrusting caused by the...
Andy Killick's PhD thesis showed that the pseudotachelites, which were Vredefort related, overprint everything else. So that Vredefort deformation is an overprint. And his pseudotachelites are all younger.
Look, look, there's a whole range of pseudotachelites. I mean, you've got the old ones. They're the ones that relate to those very early thrust faults, like the border fault. And those, you know, predate the deposition of the Transvaal by quite a way. So they are there. Big thrusts, you know, we're looking at displacements of kilometers. These folds are, these monoclinal folds are kilometers high. And they sin depositional in terms of the Wits conglomerates. And then we've got, later on, we've got these other thrusts, which are Vredefort related, and they are huge, massive things. So most of the work that you see spoken about, for example, in the Carltonville goldfield, most of those thrust faults they're forming on the decollement at the base of the Venters-Thorpe supergroup because of the rheological contrast. So though the VCR has been shattered to pieces by those thrusts, but you don't mention that. So I think you need to step back a little bit. First of all, you've got to realize that the gold is in the conglomerates. It's in primarily a sedimentary layers, number one. And number two, it's had multiple deformations of massive magnitude. You can see this very nicely in the East Rand, for example. That stuff that Page Pitts mapped. I mean, those are all Vredefort related thrusts. If you look at Page Pitts' thesis, you'll see that there's not a single mention of a northwest-southeast trending fold set. She doesn't mention it at all, but it's the major deformation of the Black Reef. It's left out of her thesis totally. So all those structures that you see in the East Rand that deform the Black Reef are all Vredefort related, post-Vredefort. So there's a whole range of different things. So I don't know. You know, you can look at microscope sections until you go blind, but you're not going to get any sensible story out of them about on a macroscopic scale. You've got to step back and look at the big picture, and you're not doing it. You're getting lost in the detail. So anyway,
I can sort of add to what I was going to say.
I'll make a couple of comments. I mean, one, we are getting somewhere because you've agreed with me on the amount of deformation in the Witwatersrand. And that is a big step forward because there are a number of publications, there are a number of reviews, and structure is relegated to almost not being relevant. So we're agreeing on one or two things. The fact that it's in a unit, you say it's sedimentary. I will tell you that the unit is a sediment, but I will also tell you that it is a dramatic rheology contrast. And you say, don't look at the detail. Well, I mean, it was the Leeds group that did that. I if anybody, stand back. And if you've got 40,000 grains and not one primary one, you've really got to just take the obvious route.
Can I just
I
come
think
in
all of
there?
us will agree. Sorry, just if I can butt in, all of us will agree that gold is actually quite a mobile element, and it doesn't take much to get it to do strange things, move around a lot. So I've got no problem with you know, shifting gold around within a host. You've got a host rock, it's got gold in it. The primary gold may have been very fine grained or whatever, tends to migrate. Gold grains, gold sticks to gold. It's got an affinity for itself. Floats on water in the right kind of environment, which we heard from Dave last week. So it does weird things, you know. But the one thing is that you've got to put the gold there in the first place, in a large quantity, and that's primary. That's the primary gold. But you have to look at the rock now in detail under microscope. You're not going to see the primary textures; they're all gone because of the mobility of gold. But they don't move very far. Gold's not moving very far.
I'm sorry, you can look at it, you can see the primary pebble texture.
Yeah.
And the gold texture is imposed on top of that tectonically.
Sorry, just say that again.
I'm saying, I'm agreeing with you. If we talk about quartz pebbles, you can look at the detail and you can see the primary texture.
In the quartz pebbles, yeah. But
Yeah.
you're looking at gold grains in quartz pebbles. What are you looking at?
In
Yeah, in
fractures.
fractures. Gold goes into fractures. We know that. Big chunks of it. I mean, you get those fractures that have this massive, like half gold. I mean, you've got some samples there at Wits, which are fractures that are, it's hard to pick them up. It's got so much gold in them. It's common.
I might just
So, yeah.
add one or two points I picked up along the way. One is spike. Personally, I would always look at the number one association as being gold with carbon. And I think Keith probably has seen an awful lot of that. The Anglo people have. And yes, lots of times it's in conglomerate
there,
and
please.
you're always showing that. But in actual fact, there's an awful lot that's in other things.
Can I come in there, Neil? Let us
Go
forget the
ahead.
gold. Let us forget the gold. I've looked at 3 occurrences of uranium and carbon. Athabasca, which I've looked at under a microscope. I have not looked at Oklo, but I've looked at a lot of the French work, and I've looked at the Wits in a great deal of detail. To me, the gold, carbon, uranium association cannot be explained by anything but a chemical system. It's geometry, which, like the carbon lead, is a single plane of mineralization running up to 300-400 grams a ton. I can't understand why everything above and below that is almost barren with gold. I've got lots and lots of assays for that. And you have this thin seam, 1 to 2 millimeters thick, which has a strike broken up by structure here and there of essentially 40 kilometers. And we down dip, we've mined it for about 2 or 3 kilometers. This thin seam called the carbon leader. And in places, it's very, very thin. In other places, it's a couple of millimeters. But it never extends into anything substantive above and below.
Keith,
And
can I cut in? When you say above and below doesn't have gold, does above and below have gold below 2 ppm or 2
Yes, it
ppb, I mean?
Yes, it does. Small amounts of gold are there.
Or is it just not have gold at South African economic levels? In other words,
what we've done
is
here,
there gold there as part of the system?
yes, what we've done is we've taken a profile through the entire mining face of 110 centimeters and taken thin sections all the way through it and mapped the gold. This is when you talk about Andy's 40,000 grains. So I worked with him, and we can add another, possibly about 100,000. We actually mapped the distribution of the gold. We did it in the VCR, we did it in the carbon leader, and we did it in the Vaal Reef. 95% or more of the gold grains are in that carbon seam or within 0.5 of a millimeter. After that, going in both directions, but normally upwards. The gold peters out slowly. You do get it leaking out, but you'll always find a carbon particle nearby. And that is the thing that I found interesting. The VCR, we don't have any kind of seam. We mapped out gold grains, but there was always carbon nearby. And we call that fly speck carbon or globular carbon. And this association of gold and carbon is very strong. And the question is why? If it's placer, that wouldn't be the case.
The carbon moved and the gold came. So,
Natural carbon in pulp concentration.
To is sort of ask, are there other questions out there that other people want to put a little bit in and say things?
Yeah.
There were even questions outstanding from last week. I'm aware of that.
Neil? Yeah,
Graham, go
Given
ahead.
here. Got
Yeah.
a couple of comments to make, and I'm going to be controversial. First thing, just in terms of bulk mining that you alluded to at South Deep, Target Mine originally started by Avgold and then taken over by Harmony. They are doing massive mining there. They're taking out the EA reefs, probably about 100 meters thick, and the mine's been going since 2000. Although I believe it's in quite serious trouble now, I'm actually surprised that the mine has lasted that long. Second point I'm going to make, if you look at the western margin of basically the Vearncombe goldfields, you have overlying the Ellsbergs, the quartzites there, you have what is called in the southern part the boulder beds, a massive package of basically polymictic diamictites that really in the southern Free State mines, nobody really paid any attention to. But when Angloval was drilling further north, the Sun Target projects, they intersected this complete variation on the boulder beds, which in Angloval parlance, now Harmony parlance, is the Dreyer's cow. Now, in that package, you've got these polymictic diamictites, the DK1s, the DK3s, and then you've got the DK6P, DK6 polymictic, and then at the top of the sequence, you've got the DK89s. Now, these things all have in common that they contain variable amounts of gold in an atypical Wits depositional setting, i.e. that I've seen some incredibly coarse grain gold in some of these boreholes. As I say, where do you sit now with this lot? Because the classic Wits placer model, conglomerate, forming a reef, quartz pebbles, some carbon, gold sitting there, etc. But now you find in this situation, you've got these atypical sedimentary rocks with significant gold concentrations. Just to sort of highlight sort of an anomaly there, the DK5...
Graham, can I cut in and ask, what's the deformation in those rocks?
I'll get to them now. There is, Julian, I'll just say, there is some faulting. Down dip of that, there's quite a big fault called the El Dorado fault. It's upthrown to the east, and I'll make a comment about that now. The DK5 package is predominantly shale. Then overlying that is the DK6P. It's polymictic conglomerate, generally sort of medium to coarse grained. But again, you've got gold scattered all the way through that package. I can't remember the exact thickness. It's not a meter or two. It could be in the order of 6, 8, 10 meters thick, and there's gold dispersed right the way through. And I've seen a similar package on the southern part of St. Helena gold mine, what they call the Stain Reef, polymictic, has gold distributed through the whole package. It's probably about a meter, meter 50, 1 meter 50 thick. So there is, from my point of view, very strong evidence that you're looking at hydrothermal gold. And my whole thinking has been turned upside down through my overview of the work that was done on Target Sun. Now, just to come back to this fault, the El Dorado fault, there was a borehole drill, DK3, has intersected a unit, which in the revised stratigraphic correlation is the DK4 TC, the DK4 top conglomerate. It turned fantastic grades. It's basically a quartz pebble conglomerate. It was decided then to drill an east deflection. We went through the same sequence. The grade increased. Now, there's a reason for that. We're drilling away towards the El Dorado fault. There was an increase in grade in this particular unit. We drilled another deflection. Well, it was DK3, DK3E, DK3EE. We got the same units, and they went through sampling and analysis. And this package, and I remember this distinctly because I processed the sampling data, it was 10 meters at 10 grams a ton. And it's Dreyer's scale has no carbon. You've got basically the polymictic end is gold, and then you get what looks like typical Wits conglomerates, the quartz pebbles. And the gold is distributed more consistently through the whole package. Now, I did have at one stage thoughts about that maybe there's partly placer and mostly hydrothermal, but I'm now more or less 99% a hydrothermalist. So there are some interesting anomalies, and I've made this comment quite often, that until there's some serious academic work done on the west margin of the Free State goldfield, the Vearncombe goldfields, we will not fully understand the Wits, and I cannot understand why. Well, Engleval was a bit averse to any academic studies, but there has been some work done. But really, the last frontier, I believe, is the Basin margin syncline, particularly up through Freddie's mine, through Lorraine, and up into Target mine, and then Target North, Sun South. I don't know if anyone wants to comment on that before I just make another comment.
Can I cut in here?
Yeah.
And say, as a message to John Bristow and to Neil Phillips, that just as we discussed this morning, New Zealand time, Spike should be giving a talk later in this series, about a week's time or 2 weeks' time. It seems to me that Graham should be giving a talk showing all this detail in a couple of weeks' time.
Yeah, I could do
I
that.
would certainly welcome that.
Yeah,
Sounds like a good idea. So that this gold series sounds like it's going to go on for the rest of the year, guys. And
Well, the gold price is pretty good.
Well, you know, and I'm diverting a bit here. That's the tragedy of the situation in South Africa. We sit with this absolute jewel box of a country, you know, gold going for miles, but we don't have a cadastral system, and we don't have a mining industry that's employing people. But, you know, therein lies another discussion, and perhaps some of the youngsters are going to fix that for us in the future. But yeah, I mean, great stuff, and good to hear from you, Graham. Glad you.
Yeah. I just want to make another point. Just Harmony wrote down the Target North sort of project by 2.8 billion rand the other day. They did some more drilling fairly far north, primarily on the VCR, and they wrote down the resource estimate there. And they're saying that there's no, that it's not feasible to start a new mine there. Okay, it's pretty deep. You'd have to sink shafts probably 2,800 meters, if not 3,000 meters. But yeah, that's more on the sort of financial side. Just some comments about Hartbeesfontein gold mine. I spent probably about 8 years of my life working on that mine. It is very extensively faulted. On the east side of the mine, you've got the what's that? Crom Drive fault. Okay, when I got there, the one shaft area had been mined out. That was done by the early 70s or the late 60s. But on the downthrow side, in the 2-4 shaft graben, it was known, and I have some experience on that the Vaal Reef package sitting immediately adjacent to the Crom Drive fault on the downthrown side was extremely high grade, and it provided Hartbeesfontein for quite a number of years the 4A shaft block. that it was just known as the high-grade block for the mining operation. I remember that basically very high grades on the basal contact there, and a lot of the contacts there were marked by carbon. And just thinking now, because I used to see a lot of the stope sampling sheets, bottom contact samples assaying at 100, 150, 200 grams a ton, and sometimes even higher. And so there is, from my way of thinking, that there is very definitely in that area a very strong link between gold grade and the presence of carbon and gold. Now, as I say, I last worked on that mine 30 years ago, and obviously I can't remember all the things I've got there, but it's always been something right from the word go, as why was there this link between very high grade Vol Reef on the down throw side of the Kromdraai with carbon and what do you call it, gold. I did pick up something from Jun Cowan the other day with these sort of plots there. I know Laurie Mint in the 76 paper, I think he inferred that basically it was a braided stream type model. I don't believe that with a Vol Reef, just on logging boreholes over a very large area, as well as some knowledge of the sort of grade distribution from basically ore reserve plans. So I do appreciate the fact that these sort of those anti-formal, synformal structures, I think there's a lot of merit in that. And I think a lot of the grade distribution does tend to follow those features. I think that's enough for me to say at the moment. And as for your suggestion, Julian, I will start putting together something that I could say. I don't think it'll be a very long talk, but I think I could make something a bit more controversial as well.
Yeah, Graham, that'll be good. Just a short, sharp presentation. So I think that's what Neil is going to say as well.
John, can I just add a little bit there?
Yeah.
You know, we talk about structure and age, relative ages and whatnot. I think the most complicated, structurally the most complicated goldfield is the Clogstorp goldfield, because you had Sin depositional thrusting, you know, those big thrust faults that Julian was talking about, like with the Rietfontein fault and the border fault and so on. And they were right there in affecting the gold and are quite intimately associated with gold. But then during the Platberg event, you had this tectonic relaxation with the massive formation of Austin grabens. So all of the earlier thrusts were reactivated as extensional faults. So you have these big grabens superimposed on a previous thrust blocks. And then you have Vredefort, and of course that goldfield is very close to Vredefort. So the Vredefort deformation, which is thrusting out of the basin from, in that case, towards the northwest, that overprinted everything else. So in the Clogstorp goldfield, you have the combination of all of these deformations in an extreme form. And that's why the geology there is so complicated. And I take my hat off to the guys who have to work in that environment. Structurally, a nightmare.
Yeah, thanks, Terence. That's fantastic. So we need a short, sharp presentation from both you and Graham with some good diagrams, just so that we know where all these outlying, fascinating areas are. So Neil, I think we'll carry on until
Look, I have called for anybody else. I don't want to leave people out who.
No, well, you've still got to get an answer to Mark Goodhart's question here as well. So I think he asked one last time as well. We didn't really.
Well, my question to Mark is: it's your term to come in if you wanted to on the channel issue, which is what you were talking about last week. But just for the benefit of everybody else, I was quite conscious, and so were others last week, that different people were talking about two quite different types of channels. And Mark, you were talking about those in the braid channels in Dave Core's terms, and erosion channels were something different. And that was a term I think Julian used and Spike used. So maybe the differentiation between those two is important, so we just don't lose everybody. If you want to say anything, you're very welcome. if you're still on board. Yeah. Anyway, I mean, there's chances other times. Oh, sorry, you're unmuted, so go ahead. Else put up your hand or just start asking.
Mark, are you still there?
Come in quickly with a proposal.
Can I put my hand up
Yes.
and ask who are the guys who are going to do the PhDs and the MSCs? Who is going to get hold of all the seismic through the Witwatersrand and put it together basin wide in the public domain?
I guess you volunteering.
I think that might. I think the person who does it may be under 50.
Well, I thought you were volunteering, Julian, but it's a very important point that you raise again, because there's still so much data out there. You know, hopefully.
My proposal.
No, hang on. You know, there's obviously Bjorn, who's doing some good work and getting his sort of students into some gold work. So we would hope, you know, that someone like that takes up the cudgels, and he's also a youngster. But we're a bit short of, you know, good gold geologists in this country at the moment, excluding the oldies, of course.
I mean, what I would say from, you know, when it's not easy to work in a mining environment and to do an academic study. And by far the best people are your good mine geologists who want to spend a few years getting an academic qualification, but they're going back to where they've worked as a mine geo, and they're doing masters and PhDs.
And you know, Julian, just to add to that, one of our big problems, and I think it's worldwide, is all of these companies now might have a geologist or two, but then they outsource everything. You know, we like the rest of the world have dozens of consultancies. We have many of them here in Somerset West and Cape Town and that, but they all, you know, who are doing the work, and you lose that continuity and, you know, really good geoscience with respect.
Yeah, look, another problem.
Spike, go ahead.
Another problem that we face in the mining industry is the lack of expenditure on infrastructure. You know, they talk about the problems at Lorraine and going north into Sun Target. The problem there was that Angloval didn't want to spend any money sinking shafts because they didn't see a future for this country. So they didn't do it. So they said, we're going to mine it until the limits of our infrastructure, and then we're going to shut down. And that's what they've done. The trouble is that there's bloody good gold down there. The same thing happened at Evander. Harmony said, we're going to buy this mine. We're going to mine it to the end of its infrastructure, and we're going to walk away. But there's massive gold in the Rollspruit base chute. It's just beyond the infrastructure. And to get open up now, with the lead times of 10 years or whatever before you get a return on your shaft sinking, it's just unthinkable, and especially in the context of BEE, where you've got to give 30% of your investment away for nothing. Who the hell's going to do that? Nobody. So it's bye-bye to the mining industry, but not because we're running out of gold. It's because of bloody politics.
Yeah, you're spot on, Spike, and it's pervasive. It's, you know, and it's not just gold, but diamonds as well.
Yeah.
And every other.
You know, you always think of the big guys, but to the small guys as well. You know, these small companies with a couple of million rand a year over to turnover, they're having to give away huge chunks of their business for nothing. So what do? They liquidate, fire everybody, and shut up shop.
Yeah.
And then we say, well, we need job creation.
Anyway, yeah,
okay.
Keith, right. Give it a few.
What Spike's comments and various things that I'm thinking about, and also looking at if you look at Julian's talk, there's an enormous depth of content there. You know, it might look like a structural map, but a lot of people work to get that diagram into that shape so Julian can give the presentation. My point is, a lot of this data is some of it's sitting in my cupboard, in my office, that has never seen the light of day. And my view is that we should start thinking towards, if everyone looks at the mineral deposits volumes done by the Geological Society of South Africa in 1986, they're substantial volumes. I'm thinking maybe we should look towards producing a substantial volume, which is essentially a memory of the work that we all did on the Wits, so that it can be used by future generations. Because there's a huge amount of it out there, which should be coordinated. All the work that Greg Hall did, all the work that we did in our basin analysis study, that should all be put into a volume. All the work that Neil and his people have done. Surely we should start thinking, and also what was done at Wits University in the past. That work should start be at EGRU and places like that. We should start looking at that work, combing through it, taking out the good bits and putting it together in some kind of review volume that's big. It covers everything that we've done so people can understand what has gone before and where to look and how to possibly develop the basin in the future.
Keith, I'm going to cut in here.
Please
So
make
I
a
assume,
comment.
Keith, I assume you're going to write chapters 1, 2, and 3.
Maybe. I
Oh.
was thinking of numerous papers which were edited and peer-reviewed, properly done, put together. Both
Keith,
sides of the argument, placer and hydrothermal, everything there, the whole lot.
Okay, well,
Yeah, but you know what?
Then we
If
write
you-
chapters 27, 28, and 29, or 99 and 100, 102. That sums it up.
Okay, I'm going to switch. I want to draw attention to Mark Goodhart's comment in the chat, where he's pointed out the paper he was a co-author with Laurie Minter, 86. That's important. That also was vaguely mentioned last week, but that paper, Mark, you'll be pleased to know, has been circulated in the last 5 or 6 days as different people have been talking about it. So it's definitely an important paper, and I think it was the channels discussion that focused around that. Look, I mean, people are slowly departing. I think we might wind this up now. There's lots and lots to keep talking about. And I'd say thank you very much to Julian. It's about 11 o'clock at night. So thanks for that. Very interesting talk. It's put a lot of stuff on the table and we'll be discussing it for a while to come, I'm sure. I want to mention that next week, I'll be speaking. It'll be more about metamorphic fluids and how they're generated, because it's simply one of those things that so many people know how to say and not really understand how they form, how they work, and why we get excited about them. And I've asked Julian if he'll chair that, so there's a little bit of independence. I don't think I've got anything more to add at that stage. See everybody in 7 days' time. And John Bristow, if you want to sort of wind up.
Yeah, Neil, thanks to everyone. I mean, again, the level of presentation or the detail is fantastic. The discussion's been tremendous, and that's one of the things we really set out to do, is get different opinions. And fantastic that people like Graham popped up, and again, thanks to Spike and all the attendees. And I hope people out there, particularly our younger geologists, have enjoyed it, and we look forward to seeing them in the future carrying on and solving some of these interesting challenges, not problems, but I would think nice challenges to have for the future. Thanks everyone. And just the last point, Neil, if people want to go and find these presentations on YouTube, just very simply go and Google GSSA YouTube, and you'll see the library will come up. And if you go to the playlist, if you look for the OGG playlist, you'll actually find this presentation will be on in a few days' time or early next week. Dave McCraw's presentation is already on YouTube and available to go and digest at your leisure. Thanks, everyone. Enjoy the rest
Thanks,
of the day.
Julian. Thanks, everybody. See you next week.
Thanks, guys.
We're so afraid you forget to press the button.